Following on from the previous video, sometimes you will be given a sequence, sometimes you will be given a sequence, and then you have to somehow work backwards to find out the original formula. So let's give you an example here. So here you're given a sequence. We've got to somehow work backwards to find out the original formula. So this is what we've got to try and figure out. And it doesn't always have to start at 1. It could start at, let's say, 3, and so on. So here. If you look at this, when you have a formula, that will then generate A1, A2, A3, and so on. So if you look at this here, when n is 1, it will generate this term. When 1 is 2, it will generate this term. When it's 3, it will generate this 3. So what's happening here is that you start out with your n. So in this case, n is 3. So from this n here, you've got to somehow generate this. You've got to somehow generate this. You've got to somehow generate this. Well, if you have a general formula here, so let's say if you have a general formula, let's say square root of n here, then this square root here will exist in all the terms here. It must exist in at the moment it exists here, but it doesn't exist here, because if your formula is truly something over square root, or the square root would be carried all the way through. If the square root must exist all the way through. So imagine this thing here as 1 over square root of 1, and then imagine this thing here. Well, there's got to be a square root in here. So let's imagine this to be square root of 4. Okay, so let's imagine this to be square root of 4. Hang on, let's just imagine this to be the square root of 4. Square root of 4. So now if you look at this, you remember if you look, let's just look at these two here. If you start out with your n, you've got to somehow generate. Hang on, you've got to somehow generate this. You've got to somehow generate this. So we're gonna guess root something. Well, look at this. 3 and 3, 4 and 4, 2 and 2. So it would be sensible to guess this square root of n, and then from the n, now we need to figure out the numerator from the n here. But we need to figure out the numerator from the n. So if you look at this here, when n is 4 here, we've got to somehow get to 5. When n is 3 here, we've got to somehow get to 4. When n is 2 here, we've got to, well, it seems as if you add 1, so it would be n plus 1. So here, for any given n, we can jump to our term here. So our answer should be like this. Our answer should be n plus 1 over square root of n. So now and make our first term to be 1, and let's try and test it out now. When n equals 1, put it into here. So that would be 1 plus 1. That would be 2, and then put 1 into here. So that would be square root of 1, and then if you tidy this up, it will give you 2. Now the next term here, well, the next term would be us putting 2 into the n here. So put 2 into the n. So this thing here will be 3. And then put 2 into here. This thing here would be root 2, and then so on. So as it turns out, given this sequence, the original formula would be n plus 1 over root n. Okay. Yeah. Okay.